Okay, for homework 1129, I'd like you to copy all of this work and the 3 words to show me that you listened. The first word right away is yellow, yellow. So we're doing special case systems where if they meet in one place, we call that one solution. Know that equations with different slope, like this example I'm showing you right here, if I have 2 equations with a different number in front of x, instantly one solution, they would meet at one place. If I have a set of an equations with the different slope, same slope, but a different y-intercept, like this one, that is a no solution. Parallel lines, they would never meet. No solution. Same slope, different y-intercepts. And of course, if I have the same slope and the same y-intercept, we call that infinite solutions, because there'll be one line graphed on top of another. Call that infinite solution, because every point on that line is a solution. So again, work on your recognition for these special cases. If you have a different number in front of x, automatic one solution, even if you didn't graph it. Same number in front of x, same slope, but different y-intercept, parallel, never meet. And then of course, the same in every way, infinite, same line. I'm going to have you look at what that looks like on a graph. Of course, on a graph, if they intersect in one place, one solution, never touch, no solution. And if they overlap, infinite. I'm going to show you for tonight's homework what this looks like when you're doing these other methods, because you need to be able to recognize it even if you're not graphing. All right, so here we go. I'm going to show both substitution and combination. If you were to solve this one doing substitution, this piece tells me what I'm substituting into the other equation's y. When I plug that in, I'll have 2x plus, but where that y used to be, I have x plus 1 now, equals 10. When I solve this and get 3x plus 1, right away, I know this is going to be a one solution. I'm getting an answer for x. I'll show you what it looks like when you're getting that no solution or many. Divide by 3, and you'll get half of the answer. Half the answer is 3 for x. To find that y number, just take that 3, put that where x is, and do the math to solve for the rest. Gives you y is 4. That one solution would be right there. If I was solving this, the math starts to be legit. It works out. If I was to graph this, they would intersect right there at 3, 4. One solution. If I was to do these same kind of problems with substitution, let me show you what happens for these other methods. So if I do this one and substitute this piece right here, what happens is I get negative 2x plus, and where that y used to be, I put positive 2x minus 4 equal to that 3. This is where weirdness happens. On a graph, easy to see, but for algebra, what happens, the x's will go away, no more x's, and all you're left with are 2 unequal numbers. That is the algebra's way of telling you this is a no solution. If I was to graph this, they would be 2 parallel lines. Different than the one I just did, a one solution. So again, if you're doing substitution or elimination and everything goes away and you're left with 2 unequal numbers, no solution. If you do substitution, watch this one and plug this one in right here. This one's a little bit harder. I'll get negative 2x plus 2. The third word is blue. Blue. Plug that x plus 3 right here. Let me show you what an infinite solution one looks like when you're doing the algebra. So when I do this one, I'll get negative 2x plus 2x plus 6 equals 6. When you get all the x's to cancel and you're left with two numbers that are equal, that's your infinite solution look using just algebra. Infinite solutions. I promise you, if you were to graph these, they would be overlapping lines. If you were to do this using the other method, which of course is elimination, I'm going to have you just copy the work for one of these, do an elimination method, but you're still kind of looking for that weirdness. If you're solving them and it's looking good, normal, one solution. If you're solving it and everything cancels away and you're left with two unequal numbers, no solution. If you solve it and everything cancels away, x's, and you're left with two equal numbers, infinite. Let me show you how this looks for the combination method. So if I took this middle one here and did the linear combo method, it would look like this. Negative 2x plus y equals 3. And I would solve that bottom one algebraically by taking away 2x on both sides. And that would give me negative 2x plus y equals negative 4. This would have nothing cancel. I would have to times the top row by negative 2 to get that positive 2 action. That would give me, I'm sorry, not negative 2, negative 1. And if I times that whole top row by negative 1, gives me 2x minus y equal negative 3. And that bottom row, negative 2x plus y equals negative 4. Again, here's how it looks weirdness algebra. Everything cancels away. And on one side I have 0. On the other side I have negative 7. As soon as you see that, that's that no solution look. That would be parallel lines. That's what the math looks like doing elimination method and you get a no solution. If you were doing elimination method and doing the infinite, you're going to be left with like 0 equals 0 with that weird stuff. All right, the third word is black. Black. All right, show me this work and those words. Give you full credit tomorrow. Good luck.